Now in this video, we are going to discuss specifically linear functions general form, and we will talk about three different forms. The first one is ax plus by equals c, where a is the coefficient of x, b is the coefficient of y, and c is a constant. So please keep in your mind that the variables only x and y, while a, b, c are the constants. So x is the independent variable and y is the dependent variable. Let's give you example what is the these equations speaks about in this form. The first one is like this one. For x minus 5y equals 7, it means the a equals 4, the b equals negative 5, and the c equals 7. Or if we have another example, negative 2x plus 3y equals negative 5, it means the a equals negative 2, the b equals 3, and the c equals negative 5. Now, the first thing that we need to learn about this specific form is how to graph the linear function if you are given an equation in this kind of form. To graph this, the most common thing is by using the conventional method, is by using the table of pair. So you have to use the table of pairs, find at least two pairs. Since we know that linear functions will form or will shape a line, a straight line, so at least we have to find two ordered pairs, and then we connect them. We plot the closed circle first. So when you find the two ordered pairs and then put or plot that two ordered pairs into the graph, into the Cartesian, and then you connect them with line. So yeah, that is the most common method to graph this linear function. So for example, I will give you this equation. This is in the ax plus by equals c form. For x minus 5y equals 7. So how to graph this? I will do the table of pairs, which is the first pair. If, for example, I choose x equals negative 2. Remember, if it's not specified the domain, you can assume that we use all real numbers for your x. So the first one is negative 2. So as usual, let's replace or substitute x by negative 2 into the equation. So I will have this statement, and then I do the arithmetic, and then I have this one. So I need to isolate y here to find the value of y, right? So by isolating y, the next step is I will add both members by 8. Remember, additional property of equality. And then I will have that negative 5y equals 15. So I need to isolate y, so I will multiply these both members by negative 1/5. In the end, I will have y equals negative 3. So the first ordered pair that I find that satisfy this equation is negative 2, negative 3. Let's go to find the second pair. Okay, since we need to at least find two ordered pairs, I will go to the next candidate of x, next option of x equals 1. So I will do the same steps. So I will substitute x by 1. I will have 4 times 1 minus 5y equals 7. And then how to find y? You need to isolate y. And with the same steps, you can do it step by step. And then I will have that y equals negative 3/5. Wow, I don't like this because even plotting integers are quite hard, and then we have fractions here. So let's just find another pair because I'm not satisfied to plot 1 comma negative 3/5. So I will find the third pair then. So let's find what is the y if x equals 3. So again, I will substitute x by 3 here, and then with the same exact steps, I will find that the y equals 1. Now this is better. Okay, we have another integers here for the ordered pairs, both the x and the y, which is easier for us to plot. Then let's plot it. So we have already found the ordered pairs, and then we just need to connect them with the line. So let me just show you the pairs that we have already found. Okay, remember that we have already had 3 pairs. The first one and the second one, since I'm not satisfied with the second one, since it is decimals or is fractions, so I'm forced to find the third one. So let me just plot the first one and the third one. So first -2, -3 here, and then we have 3, 1 here. So we have 2 ordered pairs, and then I just connect them with line. Don't forget, since it is specified again that the domain are for real numbers, it means that you need to use the arrowheads on both edges. Okay, so here it is. We have graph the equation. The next thing you need to learn is how to find an equation from a graph. So if you're given a graph, how can you figure out, or how can you know the equation in ax plus by equals c? For example, this one. Okay, how can I really can figure out directly from this graph? It is hard. So this form is not really helpful. This form, because you cannot just really get what the informations that you have from the graph, and then you cannot translate it into this kind of form. Therefore, we will avoid this, and let's pick this kind of situation for other specific forms. So now I will discuss how to find the x-intercept and the y-intercept. If you are given this kind of equation, how can you find the coordinates of the x-intercept and y-intercept? So let me just give you example. If we use the same example here, 4x minus 5y equals 7. So to find first the y-intercept, you know that the coordinates of the y-intercept, for example, this one, yeah, this is equation for this picture. So the y-intercept is here. Yes. Okay, so the coordinate is 0, comma something. Now the something is the one that we are looking for. So since we know that the value of x equals 0, it means to find the y-intercept is by substituting x by 0. So if x equals 0, then I will substitute it into the equation. I have this, right? And then since I know that the next statement is negative 5y equals 7, then I will multiply it by the multiplicative inverse to isolate y. So in the end, I will find that the y-intercept is negative 7 over 5, which if I use the coordinate, it's 0, negative 7 over 5, which just makes sense. Yeah, this is negative 7 over 5. Okay, so how to find the x-intercept? Now this is the x-intercept, the intersections of the graph with the x-axis. So it's the same, since we know that the x-intercept's coordinate will be the x-intercept, comma 0. So the y value must be 0. So if y equals 0, then this is my situation for x minus 0 equals 7. And in the end, I will skip the steps here because we are using the same steps. I will have the value of x-intercept is 7 over 4, comma 0. So it's about it's exactly 1.75. So yeah, here it is, 1.75, comma 0. So again, I don't want you to approximate by referring to the graph and then just finding the approximated decimals there. Since we know how to find exactly what's the value of x-intercept and y-intercept, I want you to do this calculation rather than you just approximate from the graph. But you can make confirmations whether your values is right or wrong by referring to the graph. Now let's speak about the second form, the slope-intercept form. So this is the form. I want you to remember that y equals mx plus b. Be careful that we only use two variables here, y and x. So the m and b are just constants, okay? Well, while the m is the coefficient of the x. So let me just give you reminder, m is the coefficient of the x that shows the slope. So m referring to the slope of your graph, and b is a constant that shows the y-intercept. Okay, while x the independent variable and y is the dependent variable. So let me give you the example. This is the first example in this slope-intercept form, which is y equals 3x minus 7, which means your graph will have the slope equals 3 and the y-intercept is at 0, negative 7. For another example, if I give you this equation, okay, in the same form, you can figure out that the slope is negative 2 over 7 and the y-intercept is 0, 4 over 5. Okay, so the first thing that we will discuss about this form is how to graph the linear function. How to graph the linear functions if you are given this kind of equation. So first you plot the y-intercept, since from this equation you can directly find out two necessary information. The first is the slope and the second is the y-intercept. So you can directly plot the y-intercept into the graph, into the Cartesian. And then since we need at least two ordered pairs, you have to find the second pair by using the slope. After you find the second pair, you just connect them with a line. That's how you graph it. It's easier than the previous form. So for example, I will give you this and how to plot this kind of equation into the graph. So yeah, this is the equation. Okay, since from the equation we have two necessary informations, which is the first one, the slope is negative 3 over 5. And then the y-intercept is 0, negative 4. So let's plot first the y-intercept into the Cartesian here. So this is 0, negative 4. And then we have to detect what is the second pair by using the slope. So since I know the slope is negative 3 over 5, it means I can use the slope is 3 divided by negative 5. 3 divided by negative 5. So 3 units go up, 1, 2, 3. And then 5 units you go left, 1, 2, 3, 4, 5. So here is the coordinate of the second pair, which I will plot it. Yes. Okay, since I know that this is my second pair and this is my first pair, I just connect them with line, and yeah, that is your graph, the graph of this function. After we learn how to graph the linear functions, if you're given this kind of form, slope-intercept form, which is, yeah, this is the graph, okay? Now let's learn how to find the equation from the graph. So let's do the opposite. So if you're given this graph, how can you figure out the equation in the slope-intercept form? Okay, let me just use the same example here. Let's just pretend we don't know what's the equation. So the first thing that you need to know to figure out an equation into this slope-intercept form, which is you need to find first what is the slope and what is the y-intercept. So you need to detect what is the y-intercept from the graph and what is the slope. For that case, you need to at least detect two ordered pairs that is really visible on your graph. So for this point, for this example, I know that this is exactly 0, negative 4, and this one is negative 5, negative 1. So by referring that, so we have to find what is the m and the b, and the y-intercept, which is b, is negative 4. So yeah, it's an easy one. Okay, and it's because this is obviously negative 4. So now, how to find the next one, the slope? Okay. For finding the slope, we just use the two known pairs that we can detect from the graph, which is negative 5, negative 1 and 0, negative 4. So for this one, I can use either the rise over run or the delta y over delta x. So for this example, I will use the formula of the slope. Since I know there are two pairs, let me just use the delta y over delta x here. So this is the second y and this is the first y. So the slope will be equal to negative 4 minus negative 1 over 0 minus negative 5. Okay, you have to be consistent. If this is the second pair, this is the first pair, it means you need to subtract the second by the first. Okay, so in the end, I will have it is equals negative 3 over 5, which is negative 3 over 5. Okay, so when I have already known the b, I have already known the m, so I'm just replacing the m and b as the constants of my equation. So this is the equation. So I just substitute the m and the b, and then I will just simplify it. It is the equation of this graph, which if I just compare to the previous one, it's exactly the same. So as long as the y-intercept is clearly visible, or you really know what is the value, you can use the slope-intercept form. But if you don't know what is the exact value, do not approximate and do not force yourself to use this form. We can use other form. Okay. The next thing that you need to learn if you're given this kind of slope-intercept form is how to find the x-intercept and y-intercept. Now, for y-intercept, of course, it's easy because if you're given this equation in the slope-intercept form, you can directly extract the information of the slope and the y-intercept. Therefore, if I'm using the same example, there will be no issue for me to find the y-intercept. The y-intercept is directly negative 4. So in coordinates, it is 0, negative 4. So the next thing that we need to learn is how to find the x-intercept, the value of x if y equals 0. So I will just substitute the y by 0 here to find the x, right? So yeah, I substitute it 0. 0 equals negative 3 over 5x minus 4. So I will isolate the x here to find the value of x. So I will add both members by 3 over 5x. In the end, I will have this, and then I will multiply both members by 5 over 3. Okay, it's just a simple algebraic steps, and then I will have the value of x equals negative 20 over 3, or it is negative negative 6 point, I think 6.66667. Okay, so let's see, is it true? Yeah, it's relevant. Negative 6.662. Yeah, it's good. Right? Yeah, the x-intercept in the coordinates. So here we go. We have the exact value. We have the exact value. So do not approximate. When you have a graph, do not approximate, or if you have an equation, you can find the value of your x-intercept and y-intercept exactly what is it. The last form that we will discuss is the point-slope form. Point-slope form. This is the form that y minus k equals m times x minus h, where h comma k is the one non-ordered pair of the linear function. Okay, so it doesn't necessarily the y-intercept only. So as long as you know at least one ordered pair, so you can put it as your h comma k on for the linear function, while the x is the independent variable and y is the dependent variable. So let me give you the example. But remember why we use point slope form, since from this form we can exactly extract two necessary information. The first one is the slope and a point or one ordered pair that we know. The first example is this: y minus 7 equals 3 times x plus 5. So referring to the point slope form, it means the m or the slope is 3, and then the ordered pair that we can know it is contained by this specific equation is negative 5 comma 7. Because why is this negative 5? Since it's supposed to be subtraction here, but this one is addition. It means actually if I translate it, it is actually x minus negative 5. So the h is negative 5 and the k is 7. Okay, the slope is 3 and the one non-ordered pair is negative 5 comma 7. Let me give you another example for us to learn. So if this is the equation in the point slope form, I can extract directly the information that the slope is negative 2 over 7 and the non-ordered pair is 3 comma negative 2. Okay, therefore the slope is negative 2 over 7 and one non-ordered pair is 3 comma negative 2. So let me give you another example. If this is the equation, the slope is 5 over 4 and the one known ordered pair is negative 5 comma negative 2. And the last example that I will give you, if this is your equation in the point slope form, so the slope will be negative 1, okay, and then the one known ordered pairs is 3 comma 5. Okay, I hope you, from these four examples, you have the idea of how do you detect the h comma k from the equation. So the first skill that we need to know about this point slope form is how to graph the linear function. If you're given this kind of equation, how to graph it. So let me give you the steps. First, you have to identify the known pair. So since from this equation, you can exactly extract two informations, which is the slope and one known ordered pair. So first identify both of it. And then after that, since you know at least one known pair, so you plot the known pair into the Cartesian axis. After you plot the known pair, find the second pair by using the slope, right? So after you have plot at least two ordered pairs on your Cartesian, then you can connect them with a line. So let's practice how to graph it if I'm giving you this kind of equation. So let's plot this equation into the graph. So the thing is, if you're given this point slope form, you don't have to convert this into the slope-intercept form and then you find what is the y-intercept, what is the slope, and then just graph it. No, you can directly graph it since you have already known that the slope is 5 over 4 and the known pairs is negative 5 comma negative 2. So first plot the known pair, negative 5 comma negative 2. So it is negative, it is around here. So let me just plot it. Okay, and then how to find the second pair, since we need the second pair to connect with the line. So use the slope 5 over 4, which means 5 units to the top, 1 2 3 4 5, and then 4 units go to the right, since the run is positive, 1 2 3 4. So this is the second ordered pair. Okay, and when we have the second ordered pair, you just connect it with the line and you have your graph. So it's simple. If you're given this kind of point slope equation, you don't have to just transform it into other form. You can directly graph it easy, as long as you know, as long as you have the idea of how to find the ordered pair and the slope. So yeah, it's really easy and fast. If you know what the point slope form means, you can directly graph it into your Cartesian from using this form. Okay, and then the next skill that you need to learn is how to find the equation from the graph. So now we do the opposite. If you are given a graph, how can you find the equation in the point slope form? For example, this graph. Well, I use the same exactly graph, but let's just pretend we don't know what is the equation in the point slope form. So how can you find out the equation? So again, always find two ordered pairs that is clearly visible to you. For this example, there are two distinctive ordered pairs that I can find. Okay, and then you are safe. You can go to find out the equation in point slope form. Don't forget, this is the form. You have to memorize it. So the first thing that we need to find, what is the slope? And then what is the known pairs? Why? Since the first, we need to find the slope by using the known pairs. If we have two known pairs, which is for this example, it's negative 5 comma negative 2 and negative 1 comma 3, we can find the slope by using the formula of the slope, right? Delta y over delta x. So if this is the second and this is the first, therefore the m equals the second y minus the first y over the second x minus the first x. This one. So I will have the slope equals 5 over 4. Now the next one is, since I know two ordered pairs, but for using the point slope form, I only need at least one. So it is only one ordered pair that I know, h comma k. So I will give you examples. So I will give you both examples by using, if I'm using negative 5 comma negative 2, what is the equation becomes? Or if I use negative 1 comma 3, what will be the equation in the point slope form? Okay, so for the first example, I will use negative 5 comma negative 2. So since I know that one ordered pairs that I know is negative 5 comma negative 2, and the slope is 5 over 4, so I'm just put all of these informations into the form. Okay, h comma k. So this is the h, this is the k, and this is the slope. Okay, see? Okay, I hope this is clear. And then you can simplify it. In the end, you have the equation. Done. Vast. As long as you know the form, as long as you can memorize the form, you can finally find the equation. Or if I'm using the second pair, so it is optional. You can choose either this one or this one. But if I use the second one, which is negative 1 comma 3, so I will just substitute all of the information I have, which is the known pairs and the slope. So the h is negative 1, the k is 3, and the slope is 5 over 4. So when I simplify it, I will have, this is the equation of the graph. See, it seems like we are speaking the same line, but it's kind of different equation. Well, actually not. Actually, this is exactly not exactly the same, but this is an equivalent equation, since both of these equations show this exactly the same solutions, exactly the same graph. But I will prove it later. Okay, so let's just satisfy it by these two equations. So you can choose either this one or this one. They both speak the same, this line. Okay. The next skill that we need to learn is how to find the x-intercept and the y-intercept. Okay, so if you're given a point slope form, how can you find the x-intercept and the y-intercept? The concept is still the same. If you want to find the x-intercept, it means you have to find the value of x if y equals 0. So you just substitute to 0 into your y. Okay, so this will be the equation, 0 into this. And then you just find the x. What is the value of x by isolating x? So don't forget, you need to distribute first this one. Okay, when you distribute, it becomes 5 over 4x plus 25 over 4. Okay, and then since I need to isolate x here, I will subtract both members by 25 over 4. So in the end, I will have this. Since I need to isolate x, then I will multiply both members by 4 over 5. And I will find the value of my x-intercept, if y equals 0. So the x-intercept is negative 3.4, comma 0. Let's check. Let's check, since we know the graph is negative 3.4. Wow, yeah, it's acceptable. Okay, so do not approximate from the graph. Okay, so you can find the exact value of your x-intercept. And then how about the y-intercept? Yeah, the y-intercept is the value of y if x equals 0. So you just substitute 0 to your x here. And in the end, with the same steps, we can find that the value of your y-intercept is negative 17 over 4. So the y-intercept is 4.25, comma 0, 4.25 positive. Let's check. 4.25. Yeah, it's exactly correct. So how can you really approximate it 4.25 from the graph. It's hard. You cannot. So do not use the graph to find the x-intercept and the y-intercept. If it is not clearly visible, you have to calculate to make sure. Since we have already learned three different forms of linear functions, now the last thing that you need to learn is how to transform the linear equation. Okay, so the first one, if you want to transform, how to transform from the point slope form into slope intercept form. So if you're given a point slope form, how to transform it into the slope intercept form. Of course, the step or the method is by isolating y. So let me give you example. Okay, so from the previous example, when I give you this graph, okay, if you still remember, you can figure out the point slope form. Why? Because if you are using slope intercept form, you need to detect, or you need to find the exact value of the y-intercept. Since this is the graph, and look at this, you cannot clearly really detect what is the exact value of y-intercept. It's not visible. Therefore, it's not wise to use the slope-intercept form. Instead, we use the point slope form to figure out what is the equation, right? So yeah, by using the same technique like before, we can figure out that there are two possibilities of your equation. So the first one is this, and the second one is this. Why they are different? Actually, it's not different, it's equivalent, but it looks like different since we are using this one, we are using this pair. And for this one, we are using this pair. Okay, so let's prove it. If it is equivalent, if it is speaking about the same line, if we transform into the slope intercept form, it should have been transformed into the same exactly equation, right? So let's just prove it. Let me begin with the first one. Okay, if I want to transform this into the slope intercept form, please accept that I will do it to the right, not step by step in its new row. So the first thing that I do is distributivity axiom. So I distribute the 5/4, the slope, right? Since I need to isolate y. Don't forget, the objective is isolating y. So after that, we still have to get rid of 2 here. Therefore, using the additional property of equality, I will subtract both members by 2. Don't forget, if I subtract by 2, and we have fraction here, so I need to transform 2 into another fraction, which is 8/4. Okay, so in the end, yeah, this is my equation, the same equation as this, but in the slope-intercept form. So let's prove it whether this second one will be transformed into the same exactly equation, since we are speaking the same line, right? So with the same steps, okay, I'm just not doing step by step. Look at this. Okay, I distribute it first, and then I add both members by 3. Okay, don't forget this 3. If you want to add it by this one, it means I need to transform 3 into the 12/4. In the end, yeah, it's the same. It's exactly the same line. Okay, so yeah, we both learning how to transform from the point slope form into slope intercept form, and by proving these two like visibly different equations, actually it's equivalent, it's the same. The second transformations that you need to learn is from slope-intercept form into ax plus by equals c. For this one, we need to regulate that the a, b, and c are integers. Okay, if this is not instructed so you can just satisfy with the fraction. But this one, I want you to learn until the a, b, c are integers. So let's use the same example. So I have already had the slope-intercept form, this one. So how can I transform this into ax plus by equals c? So please keep in mind that I will let the constant on the right member, and the x and y will be on the left. And both x and y may have coefficient. So we are not isolating x, we are not isolating y. We just collect the x and y to the left member and the constant on the right member. So what we are doing now is we multiply both members by 4. Why? Because we don't like fractions, right? So let's just multiply all by 4 to get rid of fractions. So in the end, we have 4y equals 5x plus 17. So now I need to move, okay, move this one into the left by subtract both members by 5x. So in the end, I will have this as my statement. Sorry, scroll, and then after that, I do the commutativity for additions, and this is it. I have already had ax plus by equals c, and a, b, c are integers. If it is instructed specifically that the a must be positive, for example, therefore I just multiply all by -1. So yeah, this is optional. So if you are not instructed to have positive a, you don't have to go until this last one. You just need to be satisfied with this one. Okay, so yeah, they both speaks the same line. And the last transformations that we need to learn is from ax plus by equals c into slope-intercept form. So it's the opposite from the second one. Okay, if you're given ax plus by equals c, let's transform it into slope-intercept form. So the method is by isolating y, of course. So for example, if I give you this equation, so actually it's from here, but let's just pretend we don't know what is the slope-intercept form. So how can you transform it into slope-intercept form is by isolating y. Keep that in mind. So the first step is I subtract both members by 5x. So I want to get rid of 5x from the left member. So this is the statement. And then after I simplify it, I will have -4y equals this, right? So since the y is still not isolated, I need to multiply both members by -1/4. So in the end, this will be the statement, and I will have to, with the commutativity for additions, I just switch the order, I just change the order, and then this is the equation, y equals 5/4x plus 17/4. Let's just confirm that. Yeah, it's the same. It's the same. So yeah, you have mastered all of these transformations. Learn it, practice it, and you'll be fine. Thank you for listening.